Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Relations and Functions, which is your first chapter from your 12th standard CBSE Mathematics. In this video, we'll start with the section which is composition of functions, which is in your page number 12 of your textbook. I'll start with the definition of composition of functions, which is definition 8 in your page number 12. So the definition is, so let f function from a to b and g is a function from b to c. F is a function from a to b and g is a function from b to c. Be two functions. Then the composition of f and g, composition of f and g denoted by g of f, it is denoted by g of f, is defined as a function, g of f from set A to set C. So f is a function from A to B and g is a function from B to C, means the composition of f and g is denoted by g of f and is defined as the function g of f from set A to set C, from A to C, given by means that the function is defined as g of f of x is equal to g of f of x for every x belonging to the set A. So this is called as composition of two functions f and g. This is the definition of composition of two functions f and g. So diagrammatically, if you want to represent, suppose you have a set A, this is your set A, and this is your set B, and this is your set C. A, B, C, and f is a function. Suppose x is the element and f function maps x to the element f of x. This is your function f, which maps your element x in the A set to f of x. Again, the function g maps f of x to another element, which is g of f of x. We'll probably put it a little bigger and draw this little bigger. So suppose if you have A is a set, it has the element x, and this is A set, this is B set, and we have another set, C set. Now f is a function which maps the one element, say suppose x, to another element f of x. So this is your function f, and this is mapped to, suppose this is g of f of x. This element is g of f of x, and this your g function maps this element to this element g of f of x in the set C, then which means x is actually mapped to this element using the function g of f. I'll probably try not to come into this set. Fine, so I'll probably say this is set A, set B, set C, then this goes to this. This is your g of f function. This is your g of f function which maps your x to g of f of x. Right? So this is pictorially or using arrow diagram. This is how it represents. X is mapped to f of x, and again f of x is mapped to g of f of x, and that is defined as the function g of f, which is nothing but it's mapping x to this element. So g of f is a function from a to c, set a to set c. F is a function from a to b, g is a function from b to c. Then g of f is a function from a to c. So g of f function will be always from the set. So f is the domain of the f set to the codomain of g set. So domain of f is a, codomain of g is c. So your g of f function will be from the domain of f to codomain of g, which is from a to c always. Right, now we will go to example 15 in your textbook. So example 15 is what is given. Given is f is a function. So I'll write what is given. So given is f is a function from set 2, 3, 4, 5 to another set 3, 4, 5 and 9. And g is another function which is from the set 3, 4, 5, 9. See here, when we have the composition of function, it is very important to note that f's domain is a, codomain is b. The codomain of f should become the domain of g. Only then we can define g of f. So the two functions should be in such a way that it should be from a to b, then g should start from b to c. It cannot start from any set. The g should be defined from, or the domain of g should be same as the codomain of f. The domain of g function, the domain of function g should be same as codomain of function f, right? So obviously g will be from this set to another. So these two should be same if you want to talk about g of f. And g of just to 7, 11 and 15. And it is defined as, so also f of 2, its definition is given. F of 2 is 3 and f of 3 is 4, comma, and f of 4 is equal to f of 5, both are equal to 5. That's how f is defined. Then g of 3 equal to g of 4 and both are equal to 7. And g of 5 equal to g of 9 and both are equal to 11. Both are getting mapped to 11. We have to find, so what is that? To find, we have to find the function g of f. What is the function g of f? What is the function g of f? Now whenever we want to find the function g of f, whenever we want to find any function, so there are two things that we need to find. One is the function is from which set to which set. We should know what is the domain of the function, what is the codomain of the function. That is step 1. Step 2 is we should know the definition of the function. Either it can be defined like this, f of 2 is 3, which means every element, so we say that 2 is getting mapped to 3. So 2 is mapped to 3 and 3 is mapped to 4 and 4 and 5 both are mapped to 5. So which means every element here has a unique image. Either you can write like this or we can give some definition like f of x is equal to x square plus 3, some definition can be defined. Or we can individually call out where each element in the domain goes to which element in codomain. So either ways we have to define the function. So two steps. One is the function is from which set to which set. The other one is the definition of the function. So here g of f we are defined. So solution is, see obviously your g of f function, first we are defined from which set to which set. So it will be from which set to which set. G of f function, g of f will be from the set which is the domain of f. First it will start from f functions domain set. So f is starting from 2, 3, 4, 5. So it will be from 2, 3, 4, 5 to the domain of f to the codomain of g. What is codomain of g? G is ending where? This one. So which is 7, 11, 15. Right? So your g of f will be always from the domain of f to the codomain of g. Right? So the domain of g of f is same as domain of f, and the codomain of G of F is same as codomain of G. Fine. Now this is, so we have now showed that the function G of F is from which set to which set. So that is the first part. Second part is we have defined the function G of F. Now which means we should know where 2 is getting mapped to which element, 3 is getting mapped to which element here. So we will try to find for each element. So G of F of will take the first element in this, which is 2. And G of F of 2 is what? As per the definition of G of F of X is what? G of F of X. Which means G of F of 2. That is equal to G of F of 2 means GOF. We write it as GOF, which means G of F. G of F of 2 is G of, and then we will replace this O with the bracket G of F of X, because that is the definition. G of F of X is G of F of X. That is G of F of 2. That is equal to what is F of 2? F of 2 is 3. So in the place of F of 2, I am going to put 3. So F of 2 in the place of F of 2, F of 2 is 3. So instead of F of 2, I am putting 3. So it becomes G of 3. G of 3 because F of 2 is 3. So now what is G of 3? Now G of 3 is defined as 7. So 7. So all these are given in the question. This set, this information is given in your textbook. In the question itself it is given. So we have found, so 2 is getting mapped to 7, that we have found. So similarly we have to find what is G of F of 3, next element. So 3. So 3 goes to what? G of F of 3. Now what is G of F of 3? That is G of, what is F of 3? F of 3 as per the definition given, it is 3 goes to 4. So F of 3 is 4. So instead of F of 3, I will put 4. Because F of 3 is equal to 4 as per this. Right, so now we have to find what is G of 4. Now this has become G of 4. Now what is G of 4? G of 4 is also 7. So G of 4 is 7. Now let's take the next element, third element in the domain of G of F. That is G of F of 4 is G of F of 4. That is equal to G of, now what is F of 4? F of 4 as per the definition is 5. F of 4 is equal to F of 5 equal to 5 means F of 4 is 5, F of 5 is 5. That is the meaning of this. So F of 4 is 5. So here it will become G of F of 4 will become 5. Now we should find G of 5. And what is G of 5? G of 5 is, as per the definition, G of 5 is 11. So this becomes 11. Right? Now next one is G of F of the last element, which is 5. That is equal to G of F of 5. That is equal to G of, now what is F of 5? F of 5 is also going to 5. So it becomes G of 5. And what is G of 5? G of 5 is 11. Equal to 11. So now for every element, we have defined where that element is getting mapped to. 2 is mapped to 7, 3 is mapped to 7, 4 is mapped to 11, then this 5 is mapped to 11. So for every element is mapped to a unique element here. So therefore we have found the function. This is your G of F function. Whenever you want to find a function, you should first write the function is from which set to which set. Point number 1. Point number 2 is we have to define for each element what is the corresponding image, or each element is mapped to or assigned to which element in this set. So each elements, right, in the domain should be mapped to a unique element in codomain. Fine. So this is how we will find the function. Now probably I will try to explain you like this diagram. You need not see your problem ends here. As long as you have found the function defined by this, then your problem ends here, right? But I will try to explain this in terms of this arrow diagram, just for your understanding. You need not do this arrow diagram part in your examination. As long as you do this, this is enough. For this question, this is the answer, or this is the solution, or this is the explanation, whatever. That is enough. But for your understanding, just for better understanding, I am writing this. Just for your better understanding, I am going to do this in an arrow diagram like this. So suppose, our set, now this is our A set. So I will draw it a little bigger. So this is your A set, and this is your B set, and this is your C set. Fine. Now, so what we have in A set, so this is your A, I call this as A set, this is B set, and this is C set. Your A set has 2, 3, 4, 5. So 2, 3, 4, 5. Then your B set has 3, 4, 5, 9. These elements 3, 4, 5, 9. Then your last set C has 7, 11, 7, 11, 15. Now the function f takes your 2 to 2 is getting mapped to 3. So 2 goes to 3. Then 3 goes to 4. So 3 is getting mapped to 4. Then 4 and 5 both go to 5. So 4 goes to 5 and even 5 also goes to 5. 5 also goes to 5. Then G. So this is your f function. This is your f function. Now G function. G function takes, now 3 is mapped to 3 goes to 7. So 3 goes to 7. And then 4 goes to 7. 4 also goes to 7. Then 5 goes to 11. So 5 goes to 11. And 9 also goes to 11. So this is your G function. So this is your f function, your G function. Right? Now what is f of or G of f function? G of f function is from this set to this set, which means this 2 is getting mapped to which element? 2 is mapping to 3, 3 goes to 7. Therefore your 2 goes to 7. So I can put like this. I can say your 2 goes to 7. Like that I am putting. Right? Right? So I could put this 2 goes to like this, but I don't want to cut it with the other. So this is your, then 3 goes to, 3 also goes to 7. So 3 also goes to 7. Right? This element 3 also goes to 7. Then the element 4 goes to 11. So 4. 4 goes to 11. And again even 5 also goes to 11. The 5 also goes to 11. 5 also goes to 11. So this is your function G of f. This is your function G of f. You see that? Clear? So I have just represented this, the same information, this information here, and this final information is the this one, what we defined. Fine. So this is your A set, B set, C set. So here this A set is this 2, 3, 4, 5. Your B set is 3, 4, 5, 9. And your C is 7, 11, 15. Fine. So this is how. So you can just, this is just for your understanding. I have represented how this information can be viewed in an arrow diagram. Just for better understanding how the composition happens. Composition of function means what? Mixing two functions. How the mixture of two functions happens. So this is G of f function. Fine. So all of you can pause the video and take this notes. I'll go to the next problem, which is problem number 16. Example 16. Let me erase this. So example 16 is, now what we have is, so what is given? So given in the question is, f is a function from R to R. R to R means set of all real numbers to set of all real numbers. And G is also a function from R to R, set of all real numbers to set of all real numbers. Are given by, so f of x is defined as cos x, comma g of x is defined as 3x square. And we have to find g of f and f of g functions. So to find, we have to find what is g of f. We have to find g of f and f of g. We have to find this. And we should show that also we should show that g of f is not equal to f of g. We have to prove that g of f is not equal to f of g. We have to find this function and this function. This is f of g function. This is g of f, f of g. We have to find both the functions, and then we should show that they are not equal functions. They are not equal to. Or this function is not equal to this function. That also we should show. Right? So now let's try to. So solution is. So there are three parts in this question. First is we have to find g of f function. Second part is we have to find f of g function. And third point is once you find those two functions, we should prove that they are not equal. They are not equal functions. So I will tell you how to prove this. To prove this, I will also explain you when do we call two functions as equal. Only when you know when we call two functions are equal, then we will know when we can say two functions are not equal. Right? So let's do the first part first. Right? So we have to find g of f. To find g of f first. That's the first one. The solution, first part is we have to find g of f. Now, so whenever we want to define a function, I said we need two steps. One is the function is from which set to which set. The second one is definition of the function, like this. F is a function from R to R. This is one information that we need to write. Then second is the definition of x. Here f of x is cos x. Here it is defined as a definition. Not individual elements mapping is not given. Rather, a definition is given. Similarly, g is also from R to R and g is also defined. Now we have to find f of g and g of f. Now, what is g of f? So g of f, to define this function g of f, we should define the first it is from which set to which set. So g of f is from, now again I told you, g of f function will be starting from the domain of f. The domain of this function will be domain of f. What is domain of f? This is domain, this is codomain. So it starts from this R to, it will go to the codomain of g. What is codomain of g? It is this R. So your g of f will be from this R to this R. From this set to this set. Both are R. So it is from R to R. The g of f, the domain will be the domain of this, the starting set, which is domain set, will be domain of f. And the ending set, which is the codomain set, is the codomain of g. The codomain of g is this. This is domain of f. Right? Now, so we have done the first information is done with respect to function. Whenever we need to find a function or define a function, first we should say it is from which set to which set. That part is done. Your g of f is from R to R. And what is the definition of g of f? So your g of f of x will be equal to g of f of x as per the definition of the composition of function. So g of f of x is g of f of x. So that is equal to g of, now what is f of x? F of x is cos x. So we'll put cos x. So we have to find g of cos x. We have to find g of cos x. Now what is g of cos x? G of cos x means g of x is what? 3x square. So this is like g of x. You treat this as x. So g of x is 3x square, which means 3 into x square. Right? Your g of x, if x comes, I have to put x here. I have cos x. In the place of x, I have cos x. So wherever x is there, I have to put cos x. So this is 3 into cos x whole square, which is same as 3 cos square x. So that is your g of f of x. So what is our g of f of x? The g of f of x is 3 cos square x. So we have found the function. So we have defined that the function is the from which set to which set. Also we have found the definition of the function. This is your g of f of x function, which is 3 cos square x. Now similarly, we should find f of g. So second one is to find f of g. To find f of g function. Now f of g function, again when we have to define the function, we should show f of g function is from which set to which set. And this set will be from, the starting will be the g, you have to see the g, it will start from the domain of g. The domain of f of g function is the domain of g function. So domain of g is R, this function. R to, the codomain of f of g, it will go to the domain of, codomain of f. What is codomain of f? Codomain of f is this R. So this R. So f of g will be a function from this R, this set R to this set R. So it will be from the domain of g to codomain of f. Here it is from domain of f to codomain of g. domain of f to codomain of g, that is your g of f. F of g will be domain of g to codomain of f. Domain of g to codomain of f. Domain of g is R and codomain of f is R, so it is from R to R. So we have defined that the f of g function is from which set to which set. Just that is done. That part is done. Now we'll have to define the function. So f of g of x. So we have done the set is from which set to which set. Now we should write the definition of the function. That is equal to f of g of x. F of g of x is f of g of x. That is equal to f of, what is g of x? G of x is 3x square. So, but that we should put instead of g of x is what? 3x square. So it is f of 3x square. Now what is f of 3x square? F of x is what? F of x is cos x. When f of x is cos x, right? F of 3x square will be cos of 3x square. Which means f of x means cos x. So if it is x here, I have to put cos x. If it is 3x square, then I should put cos of 3x square. That is f of x. You think this as x. F of x is cos x. 3x square should be thought as x. We should think 3x square as x. So f of x is what? Cos x. But in the place of x, I will put 3x square because in the place of x, I have 3x square. So this is your f of g function. So your f of g of x function is what? Cos 3x square. Now obviously if you look at these two, so we put the bracket here. So obviously if you look at this, even if you don't put it, it is understood that it is cos of 3x square. Right? It is understood that it is cos of 3x square. Even if you put the bracket, nothing wrong. So I'll put properly write it. So cos of 3x square. Fine. Cos of 3x square. Now from the look itself, we see that they are not equal. Right? This is 3 cos square x is different from cos 3x square. So we can immediately say g of f is not equal to f of g, but we'll have to prove in a more a technical way, right? In a more mathematical way, we can't say looking at this they are different. Look wise we cannot say things are different or things are same in mathematics. We have to support that with a valid explanation. So the explanation that to show that these two are different functions, g of f is 3 cos square x, f of g of x is, or f of g is cos 3x square. So these two are different. Look wise they look, because 3 cos square x we know it is not same as cos 3x square. Look wise different, but we will give one example and say that they are different. So to show that these two functions are different, you try to understand what are equal functions. Right? So there is one more definition that I am writing here, just for your understanding. When do we call two functions as equal functions? Right? So equal functions definition. Equal functions. Now we'll say let f function from a to b and g function from a to b are two functions we say f and g are equal functions if f of x is equal to g of x for every x belonging to the domain A. When do we say two functions as equal functions? The function f from a to b and the function g also should be from the same set a to b. So whichever set f is from. So f is from a to b means g is also should be from a to b, and your f of x should be equal to g of x for every x in a, which means the image of any element of f should be same as the image of any element of x in a under g. So the image of x, any element x under f is same as image of x under g, which means f of x should be equal to g of x for every x belonging to the domain. So whenever we take any x from the domain, if f is taking that element to some y, then g also should take it to y. If x is going to z, g also should take it to z. So f of x should be equal to g of x. The image should be equal for every. The image under f should be same as image under g. Right? So then we say if this is true for every x, then we say that the two functions are equal. Then it becomes not equal when if we say that two functions are not equal. Two functions are not equal. Suppose they are from the same set a to b to a to b. A to b, again g is also from a to b. Suppose if we are finding one x in a such that f of x is not equal to g of x. If we can find one element, for one x, if I take one element from the domain, and if I find the f of x value, and then if I find g of x value, and if they are different, even for one element, if it is different, then we will say that the two functions are not equal. So for the functions to be equal, f of x should be equal to g of x for every x. For every x, f of x and g of x should be equal. Then we call the functions as equal. To prove that the two functions are not equal, then even if for one element, if the f of x value is different from g of x, which means f of x is not equal to g of x for at least one x in the domain of the functions, then we call the two functions as not equal, even if it fails for one element from the domain. Right? So that's what we are going to do here to show that they are not equal. So which means we will find one value from the domain x. Right? So here see, g of f is also from R to R, f of g is also from R to R. So the first condition is taken care. Both the functions should be from a to b and a to b to show that these two functions are equal or not. Now the sets are equal. Does f of x equal to g of x? Are they equal? F of x and g of x are equal. That we got to check. That should be equal for every x. Which means for every element I take from x, any element that I take from this R, which is same as this R, because both are from R to R, R to R. Any x that I take from R, my g of f of x and f of g of x are equal for every x coming from this, then we say equal. To say that it is not equal, we'll find one x from R, we'll take one real number and we'll find what is g of f of x for that number and f of g of x for that number, and if they are not equal even for one number, then we'll say they are not equal. So we'll say take that one element, we'll say x is equal to 0 belonging to R. We are taking the number 0 from the domain R, right, which is same as this R. So I'm taking for this one I'm taking a 0 from this domain, and let's find what is g of f of 0. What is g of f of 0? That is g of f of 0 is what? G of f of 0. G of f of 0 is what? 3. We know the function of g of f of x. G of f of x is 3 cos square x. So g of f of 0 will be 3 cos square 0. That is equal to 3 into 1 square, because cos 0 is 1. So 1 square, which is 3. So similarly, let's find what is f of g of 0. For this function, what is the value where the 0 is getting mapped? For g of f, the 0 is getting mapped to 3. For g of f, the 0 element is getting mapped to 3, and f of g, the 0, let's check where this 0 goes to. So that is equal to, what is f of g of 0? That is cos of 3. That is cos of 3 into 0 square, because x is 0. So that will become cos 0. And what is cos 0? 3 into x, 0 square is 0, 3 into 0 is 0, so cos 0 is 1. So the 0, the same element x, which is 0, g of f gives you 3, but f of g gives you 1, which means your g of f of 0 is not equal to f of g of 0. It is failing, even if it fails for one element. Here one element only we took and we checked. If it fails, which means they are not equal. Therefore, we can say, therefore, your g of f is not equal to f of g. These two functions are not equal. G of f and f of g, they are not equal functions, because it fails for one element. Even if it fails for one element, they are not equal functions. If it is equal means any element that I take, if I find f of g of suppose 1 gives me suppose 5, my f of g of 1 also should give me 5. For any real number that I take, if I get the images are equal for all the numbers, then they are equal. Even for one number, if it is not equal, here for 0 it is not equal. If I take x as 0, it is not equal. Here I got 3, here I got 1. They are different. Then they are not equal functions. So therefore, g of f is not equal to f of g. So that is also proved. Because for one value it is failing. Even for one value, if it doesn't match, then the two functions are not equal. If for all the values it matches, for all the values if it match, then we say equal function. For one value if it fails, then it is not equal. So here it fails for one value where x is equal to 0, it fails. Fine. So all of you can pause the video and take the notes. I'll stop the session here. You can watch my next session for the continuation of this. Thank you for watching. See you all in the next session. Thank you.